Okay, viewers all over the world, uh, we shall be considering episode 3. Episode 3, we shall be considering episode 3. And the question says, find the value of 2x minus y, comma, if x plus y equals to 8, and 4x minus y equals to what? 22. That is the question. So this question is simultaneous. This question is simultaneous equation. And the simultaneous equation is from the topic algebraic equation also, algebra. Simultaneous equation is from the topic we call algebra. Yes. And in resolving a simultaneous equation, we have at least 3 methods of solving a simultaneous equation. We have 3 methods of solving simultaneous equation. The first method, we can use the elimination method to solve simultaneous equation. We can equally use our substitution method to solve the simultaneous equation. And also graphical solution. We can plot graph by simultaneous equation. But in solving a simultaneous equation, there's what we call a uniform coefficient problem and non-uniform coefficient problem. I just want to give you an example here before we come to the main problem, before we start solving. Let's assume that you have something like this, using this as an example, x plus y equals to 8 and 4x minus y equals 22. Let's assume that this is A and this is B. Then let's assume that we have a 2s minus y equals 5, and we have a 3s plus 2y equals to what? 2. Okay, looking at these two questions here, this is A, s plus y equals to 8, 4s minus y equals to what? 22. You see that a simultaneous equation comes in pairs. So, and this is called a simultaneous linear equation because the highest power here is what? 1. And likewise this. So it's called a simultaneous linear equation. And linear there means that it's what the highest power is just 1. And the simultaneous equation comes in pairs, meaning that we must solve the two equations simultaneously. This is equation 1, this is equation 2. Okay, this is how it is. And this one also equation 1, and this one also equation 2. This is how it is. So the excess of given these two examples is what we call what? A uniform coefficient problem. This is an example of a uniform coefficient problem, and that is what? The question A. Simultaneous equation A is the what? The example of a uniform coefficient problem. Why is it called uniform? Because the coefficient of y here is 1 for equation 1. The coefficient of y here is also 1. Do you understand? So in as much as the coefficient of one of the variables, yes, for either equation 1 and equation 2 are the same, then it means that this is a uniform coefficient problem. With this one, you can easily solve using elimination method. Using what? Elimination method. So for you to apply elimination method, you have to make sure that the uniform coefficient, uniform coefficient problem, is meet up. Yes, we are able to meet up with a uniform coefficient arrangement because now, like the second one, which is B, look at this 2s, this 3s, they are not uniform. They are not uniform because the coefficient of s and the coefficient of s for equation 2, they are not the same. And when you come to the y side of it, you discover that this is the coefficient of y here is what? 1. The coefficient of y here is 2. They are not uniform. This is the example of one non-uniform coefficient problem. So uniform coefficient problem, despite the fact that the coefficient of this s for equation 1 and coefficient of s in equation 2 for a, that they are not the same, but in as much as it meet up, the y are the same. This is the example of a uniform coefficient problem for a. But this one is what? Example of non-uniform coefficient problem. So for you to use elimination here, you have to make sure that you make either the coefficient of x here, that's in equation 1 and 2, to be the same. To be the same, whatever that is here should be here before you apply elimination in this second example here, which is example B. But substitution, you can use substitution method for both A and a B. Substitution can go for any of them, but elimination can only go for this, and it cannot go for this. Understood? So that is just it. So let's come back to what? Analysis. Solution. This one solution. So let's take it as our part 1. So applying what? Applying elimination. Applying elimination method. Elimination method. Under what? Under uniform. Under uniform. Uniform. Under uniform coefficient. Under uniform coefficient problem. Okay, so that is s plus 1 equals to what? 8 as your equation 1, and 4s minus 1 equals to what? 22. Okay, without waste of time, you can say that this is an example of a uniform coefficient problem. That is an example. Yes, it's an example of a uniform coefficient problem. And why is it like that? When a variable is maintained at the same coefficient, you can easily what? Eliminate it. With this question now, that is equation 1 and equation 2, we can easily eliminate, cancel the one that are uniform. Like what? The coefficient of y here and the coefficient of y in equation 1 and equation 2, we can cancel it. Okay, so we can do like this. Then just add. You add equation 1 and equation 2. By adding equation 1 and equation 2, let's see, s plus 4s will give us 5s. Okay, sorry. Will give us 5s. Then plus y minus y cancel itself. So that one have cancel. Then 8 plus 22 will give us our 30. So at this point, you divide both sides by what? By 5. 5 all over. You are dividing both sides by 5. Equals to 130 over 5. Therefore now, s now equals to what? 6. S equals to 6. So that is it. So here now you discover that 5s equals to 30. Divide both sides by what? By 5. Because you are looking for the value of s. So 5s all over 5 equals to 30 all over 5. Then s now equal to 5 into 30 will give you 6. So we continue with what? The part 2. The part 2 of this of the analysis and solution.